Hello everybody, today we're going to talk about segments some more, and by the end of the lesson, hopefully you can answer this question. How are midpoint and length of a segment on a coordinate plane determined? So you'll need your calculator, your notes, and something to write with. Okay, we've already talked about some basic vocabulary, and then we went over some basic stuff on segments and on angles, including segment addition and angle addition, and how to measure them. And then make sure you turned in your worksheet today. Remember to show your work for credit using our formulas. And then we talked about congruent segments and angles and how to construct those, and then how to solve problems with congruent segments and angles. So make sure you turn in that worksheet as well. On our next set of notes, if you can title on 1-3, midpoint and distance. And remember, I have a note catcher for these notes, so if you would like to use that, please grab one. So again, midpoint and distance. Let's start off with midpoint. The midpoint is the point in the middle of a segment that makes two congruent smaller segments. So if I have this segment right here that I'm drawing, the midpoint is going to be the point in the very middle. So if the entire segment was 10 units long, then this segment is going to be 5 units long, and this segment is going to be 5 units long. Sometimes we put little dashes on them like we talked in our last class, and this means that those two segments are congruent in length. Okay, so let me give you a problem on the one-dimensional number line. Well, maybe pause the video and try solving this problem. What is the midpoint of -4 and 3? So some of y'all might have plotted the points and then realized the midpoint's somewhere in the middle, and you kind of went to the left and to the right inside, and you got somewhere around this range right here. So any number between -1 and 0 was a really good guess. If you guessed -1/2 or -0.5, awesome, that is the midpoint. But the numbers I give you aren't always going to be small, so we want to make sure we can use a formula. And the formula we're going to use for midpoint in the one dimension is xm, meaning x midpoint, equals x1 plus x2. So our two endpoint values, and then we're going to divide them by 2. So basically we're averaging our endpoint values. I'm going to plug in -4 for my left endpoint and 3 for my right endpoint. And then if you need a calculator, you can type this in the calculator. If you can do this in your head, that's great also. So -4 plus 3 is -1 over 2. So -1/2. If you need help using the calculator, then make sure whenever you're starting off with this negative number that you use the negative button. And if you want to type in a fraction, you're going to hit Control Divide on the Inspire, and that's how you can type in a horizontal fraction. And again, the negative button's right here. So if it's in the lead, you want to use the negative button, not the minus button. Sometimes it has a little bit of an issue. Okay, so -4 plus 3 over 2 is -1/2. If you wanted to make that into a decimal, don't hit Control Enter. What you should do is type in that fraction and put a little decimal at the end. So the decimal button's right here. And if you type in your fraction, -1/2, as a decimal, you can type it in as a horizontal fraction or just the division. It'll convert it to a decimal for you real fast. Okay, let's do another problem. Pause the video and try answering this question. The midpoint is -1 and an endpoint is 4. The other endpoint is... Okay, hopefully you have thought about this problem and you unpaused your video. So some of y'all might have plotted these points. If you guessed somewhere in here, then you need to reread the question because it's looking for the other endpoint, which is telling you one of these is the midpoint. So the midpoint is -1, which means the other endpoint has to be somewhere over here. So guessing in this range is a really good guess. But let's use our formula because, again, the numbers might be bigger. When I plug stuff into my formula, my midpoint is -1. So I'm going to plug that in for xm. And then 4 can be either x1 or x2. It really doesn't matter. Once you plug them in, just drop the subscript so you don't accidentally square a number. So I have -1 equals 4 plus x over 2. And the scariest looking thing I would say for y'all is this fraction right here. Remember, a fraction is just division. So to get rid of that 2, I'm going to multiply both sides by 2. That cancels out the 2 on the bottom, and I'm left with 2 times -1, which is -2, and then 4 plus x on the right. If I want to solve for x, to get 4 to the opposite side, I do the opposite, which is -4. So -2 minus 4 is -6. Make sure you're bringing down those equal signs and you're showing every step. So -6 was the other endpoint, if that's what you guessed. Good job. Okay, now let's extend this 1D into a 2D formula. So I have these 2 points, and I want to find the midpoint of segment AB. You're going to find the midpoint of the x values and the midpoint of the y values, and that's how you find the midpoint. So my x values, remember a point is written x comma y, x comma y. So my first x values here, so my x values are the first values in each point. So my 2 x values are -3 and 4. So when I'm trying to find my midpoint, I'm going to plug in -3 for x1 and 4 for x2. So -3 plus 4 over 2. And then for my y values, it's 2 plus -2 over 2. So -3 plus 4 is 1/2. And then 2 plus -2 is 0. So 0 divided by anything is just 0. So 0.5 or 1/2 comma 0, that's the midpoint. And you can kind of estimate, that makes sense that it's right there. Okay, next question. What is the midpoint of segment CD? Okay, so CD, let's use the formula because I don't have a graph here. So my 2 x values are the first numbers. So -2 and 8, I'm going to add those together, divide by 2, and then my 2 y values are the second numbers. So 5 and -12, I'm going to add those together. Again, you can use a calculator if you want to. -2 plus 8 is 6, divided by 2 is 3. And then 5 plus -12 really means 5 minus 12, right? A positive and a negative mean minus. So that's -7 over 2, which is -3.5. And you could have just typed that in the calculator as well. Okay, let's do one more. This one's scary. Okay, what is the midpoint of EF? It's got some decimals. Again, we're going to use the formula. So for midpoint, we're going to first average those x values. So those are the first numbers in each set. So I'm going to say 2.5 plus -6.2 over 2. And then the y values, -7 plus -3.8 over 2. Okay, just type it in the calculator and you should get -1.85 and 5.4. Pause the video, make sure you're taking these notes, but also make sure you're practice typing in the calculator and getting the right answer. Okay, let's do one more question on midpoint. What is the endpoint of OR if the midpoint M is -318 and R is 4, -4? Okay, so I see midpoint, write down the midpoint formula, but this one's a little bit different because they're giving you the midpoint, not both endpoints. So whenever I have a problem like this, I like to focus on the x values and then focus on the y values. So remember, the x value midpoint formula is xm equals x1 plus x2 over 2. And I'm just going to focus on the x values. So those are the first values. This -3 is my midpoint, so it's going to go right here. This 4 is my other endpoint, so it's just going to go either here or here. It doesn't matter which one. Again, drop the subscript when you plug everything in, and then we're going to solve it. I like to get rid of the fraction first, so I like to multiply both sides by 2. So I'll get negative 6 equals 4 plus x. Subtract 4 from both sides, and I get negative 10. So my x value for O is at negative 10. Now I'm going to focus on the y values. So the y midpoint formula is the same thing, but with the letter y, and we're going to use the y values. So 18 is the midpoint for the y value, so it's going to go here. And then negative 4 is the other endpoint. So I'm just going to plug everything into my formula, and I'm going to solve it. It's just an Algebra 1 question right now. I don't like the fraction. Let's get rid of it. I'm going to multiply both sides by 2. So it cancels out, right? Just like it did over here, it canceled out. And so I get 36 equals negative 4 plus y. To solve for y, I need to get rid of this negative 4. So I'm going to add 4 to both sides. And I get 40 equals y. Okay, we're almost done. So my endpoint is an x value, comma, a y value. So my endpoint is the x value, comma, the y value. So negative 10, comma, 40. Okay. So tape that in. Whichever is the scariest side, tape that face up to you. And now let's talk about some points that are maybe not the very middle, but they're kind of in between 2 points. And this is called partitioning a segment. So a midpoint is a very famous partition of splitting it in a ratio of 1 to 1. But what if we weren't splitting it in a ratio of 1 to 1? So let's just start off by making sure we understand what our segment looks like. So I have this point 3, 4, negative 4, and 13, 11. So I'm going to plot 3, negative 4. 3 is between 2 and 4. Negative 4. So I go right 3, down 4. And then 13 and 11 means I'm going to go right 13 and then up 11. So like right there in between 10 and 12. One thing you need to make sure you do is label your points. So I'm going to label this one was A and this one is B. Okay, so there's my segment. If I wanted the midpoint, it'd be somewhere around here, right? Like we can kind of estimate. We would want to use our formula. My line isn't the best line ever because I just freehand drew it, but it's somewhere over here if I had to make a good guess. Here's my question. Let me have you write down the question and then we'll talk through it. What are the coordinates of C, the point that partitions AB into a ratio of 3 to 2? Okay. So it's a little bit like 3 to 2. It's a little bit more than, like this is a 1 to 1. So 3 to 2 means it'd be somewhere over here maybe. So again, my line isn't the best line ever. So let's do some math. How can we think about this? I think the easiest way is to focus on your x values or the horizontal line. So if you can imagine yourself drawing a right triangle, I'm just going to focus on the x distance. And we already know how to find this x distance because it's the distance from the x value of 3 to the x value of 13, right? Those are my two x values right there. How do we find the distance? Distance equals the absolute value of x2 minus x1. So 13 minus 3 or 3 minus 13 and just make it a positive number. And you get a horizontal distance of 10. Okay, so this distance from here to here is 10. But we want to break it up into a ratio of 3 to 2. So I'm going to make an algebra problem out of that. And the fastest way I've found is to just tag on a little x there. So I'm going to say 3x plus 2x has to become 10. There's other ways to do this, but this is one way. So again, 3x plus 2x becomes 10. So 3x plus 2x equals 10. Let's just solve this really quick. Combined length terms, I get 5x equals 10. So divide by 5, I get x equals 2. Okay, just give it a second. Okay, we've done a lot. Now, if x was 2, that's not even on my segment, so that doesn't make any sense. What you're going to do is plug it back into this little equation that I just made up. So I'm going to plug in 2 for my x value. So 3 times 2 plus 2 times 2, let's just check. 3 times 2 is 6. 2 times 2 is 4. Do they add up to make 10? Yes, they do. So from A, I'm going to either go right 6. I'm going to break it up into a 6 and a 4. So if I go right 6 from A, remember A's at 3. I know my scaling's a little silly. So I'm going to go 1, 2, 3, 4, 5, 6. So now my X value becomes 9. Okay. And then I'm just going to go straight up until I hit that line. And so my Y value is 5, right? 5. So 9 comma 5. So that's the point that is going to partition or divide my segment into a ratio of 3 to 2. Okay, let's go over another example so you can kind of see how it works out with other numbers. Okay, so I have the same situation, same points. I was being really creative with my slideshow skills. So A is at 3, negative 4, and B is at 13, 11. Okay. What are the coordinates of C, the point that partitions AB into a ratio of 7 to 3? Okay. So what we're going to do is, again, think of that right triangle, and I'm going to focus on that horizontal distance. I could have drawn that line, I just didn't draw it. So the distance, again, we're going to look at the X values of A and B, and I'm going to subtract them and make sure it's a positive number because my distance always needs to be positive. And then I'm going to make this into an algebra problem by just tagging on an x. So 7x plus 3x equals 10. Let's solve it. 7x plus 3x is 10x. So divide by 10, x equals 1. 1 doesn't really make sense, or even moving it 1 away doesn't make sense because this is really tiny and this is really large. So compared to 7 to 3, that doesn't look like a 7 to 3 ratio. So we're constantly thinking through the problem. I'm going to plug it back into my equation. And so I have 7 times 1 plus 3 times 1. We're going to check. 7 times 1 is 3. Sorry, 7 times 1 is 7. 3 times 1 is 3. Does it equal 10? Yes, it does. So I'm going to go to the right 7 or to the left 3. And I'm just going to go straight up on my line. So when I go straight up, I have an X value of 10. So remember, we started at 3. If I go over 7, 3 plus 7 is 10. Okay, I'm going to go straight up on my line. And again, if my animations were a little bit better, it'd be really obvious. But my Y value is 7. So 10 comma 7. That's where my point is. And that looks like a ratio of 7 to 3. Like this one's a 7, this one's 3. Okay. So distance formula, again, we can find the distance of things. If it's the horizontal distance, it's x2 minus x1. We call that distance in 1D. But if we're going in 2D, this is the distance formula. Because we want to find the distance of the x values, square them, plus the distance of the y values, square them, and then we take the square root. It's all based off of Pythagorean theorem. So let's solve some problems. What is the length from A to B? And we're going to use that same A to B that we are working with on the other two problems. Okay, I know this is a 2-dimension. I know 1D, 2D. I know this is a 2D problem because I have an X and a Y value. Okay, if it was 1D, it would just be a number line. You would just have X values. So since I have a Y value, I have to use the 2D formula. Okay, I'm going to plug everything in. So when I plug them in, I'm subtracting the two X values. Those are the first two numbers. It doesn't matter which order you plug them in as long as you plug in the X values together. Not these two values, but the two first values. So that's 13 minus 3, and then I'm going to square them. And then for the next part, my two Y values, the second values. So it could be negative 4 minus 11 or 11 minus negative 4. Be careful with your negatives because I'm subtracting negative 4. And you know that's a plus, but I'm going to leave it as minus right now. Okay. When you type it into the calculator, I don't want you to type in the square root at first. I want you to type in everything underneath the square root. Make sure you use your parentheses. Make sure you use your exponent or caret if you would prefer the caret to raise it to the second power, that's fine. I like to use the x squared button. And then make sure when you're subtracting a negative, you use the minus sign for subtract and you use the negative sign for the 4. Otherwise, it might multiply. It might think you're trying to multiply numbers together here. Okay, so I typed in, and it should look something like this. Pause the video and try typing it in. And when you hit enter, you'll get 325. This is me screenshotting the calculator. I know it's really blurry. Okay, so the distance is the square root of 325 because it's the square root of what was underneath that radicand. So right here, this is the exact answer, but it's not simplified. Remember how you learned how to simplify fractions? Like if you answered 4/8, that's wrong, right? The answer should have been 1/2. So we want to be able to simplify fractions. We want to be able to simplify square roots. So in case you don't remember how to simplify this square root, let me paint a picture for you. So I'm going to do the sky and the grass and a tree, because we're going to do a factor tree. Okay, so when you do a factor tree, you think what multiplies to make this number? It ends in 5, so it's divisible by 5. So 325 divided by 5 is 5 and 65. 65 ends in 5, so that's obviously divisible by 5. So that's 5 and 13. So this means the square root of 325 is the same thing as the square root of my end branches, 5 times 5 times 13. I like to rewrite them from least to greatest. Remember, you group your little twins. The square root of 5 times 5 is just 5, so I can bring it out one time. And this little lonely guy's got to stay on the inside. So the square root of 325, the exact answer, simplified, is 5 square root of 3. Now, I know on the Inspires you can just type in the square root of 325 and it'll get you the answer, but I do want you to show your work on these questions because they are going to get a little harder throughout the year. How do you type in a square root? You hit the control button and then you hit the x squared and that'll square root it for you. Square root of 325. If I want the decimal approximation, you need to type in a decimal on the Inspires. Remember the decimal button's right here. And then you'll get this decimal, just round it to 2 decimal places for me. So about 18.03. So we have 2 answers, the exact and the rounded approximate answer. Okay, I always want you to simplify your answer. Let's do another example. What is the length of PL? Okay, so here I have P is, I just made up these numbers. P is negative 512. L is negative 916. Let me have you pause the video and try doing this one on your own for a minute. Okay, so hopefully you did it. I like to label them XY, XY, so when I plug them into the formula, it just makes it a little bit easier for me. So first I'm going to look at the X values and subtract them. They're the first 2 terms, the first term here and the first term here. Be careful with negatives. Make sure when you subtract them, you don't drop the minus sign. So it's x2 minus x1. So it's negative 9 minus negative 5, which you know that's positive. So you can make that a plus if you really want to. And then for the y values, my 2 y values, 16 minus 12, or again, 12 minus 16 is fine also. How do I want you to show your work? Show me what you're plugging in. And then I want you to type in everything underneath the square root. So you're going to type in everything underneath the square root in the calculator. There's my animations. Again, I have 2 negatives here. This right here, this leading negative, you need to make sure you use the negative button. Okay? This would be a minus and this would be a negative. So be careful when you're typing it into the Inspire. Make sure you're using your parentheses and you're not forgetting to square it. So you're going to type in the radicand into your calculator. That's the thing underneath the radical. I guess maybe vocab lesson really quick. This symbol is called the radical. And then what's underneath it is called the radicand. It's been a long time since you've seen those words, probably. Or maybe never, I don't know. Okay, so I'm going to type that in, and then I get the square root of 32. So the distance is not 32, it is the square root of 32. So can we simplify that? Can we simplify the square root of 32? Let's paint a picture. How do we do that? We do a factor tree. So it's even. I know it's divisible by 2. So I'm going to divide it by 2, and I get 2 times 16. 16 is also even. Some of y'all will divide it by 2 again. I think when I did this in class, we did 4 and 4, because that's what y'all said. 4 times 4 is 16. 4 is even, that's 2 times 2. 4 is even, that's 2 times 2. So all of my end branches, there is 1, 2, 3, 4, 5 2's. That means the square root of 32 is the same thing as square root of 2 times 2 times 2 times 2 times 2, 5 2's. We group our little twinsies, we bring them outside, so I'm going to bring it out once, twice. So I get 2 times 2 on the outside, and this little lonely 2 has to stay on the inside. 2 times 2 is 4 square roots of 2. Okay, so that's the simplified version. And again, you can use your calculator to check, but I do want to see your factor tree somewhere. I want to see you thinking through how to simplify. I don't want you to go from here to here without any work on the side. So you would type in Control X squared to get the square root symbol, and you'll get the square root of 32. And so that'll tell you, yes, it is 4 square root of 2. So yay, we did it right. And then to get me the approximate, you're going to type in the square root of 32 or 4 square root of 2, and then put a little decimal there. Hit the little decimal button, and it'll convert it to a decimal for you. And just round to 2 decimal places, 5.66. Okay. Let's do one more example. One more example. And then I think we'll be done for the day. All right, this was a 2-day lesson, right? Okay, so what is the length of no? Okay, n is at 3.5, comma 8, and O is at negative 2, comma, sorry, what was I typing? Negative 2, let me see. There we go. Negative 2.4, comma 3.1. Okay, so we're going to find length. Again, remember, length means distance. And since this has an x and a y value, that means it's 2D. So we're going to use the 2D distance formula. Okay, I like to label them x comma y, x comma y. I put my little subscript 1, 1, 2, 2, so that it just makes it a little easier for me to plug them into the formula. So start off by subtracting the 2 x values. It doesn't matter which one goes first. I'm going to use x2 first, so negative 2.4 minus 3.5 squared. Okay, now I'm going to do the y values. 3.1 minus 8 squared. Okay, so we're going to type in the radicand into the calculator. So the thing underneath the square root, type that into your calculator. Make sure you use parentheses, and you square it, and use your negative. Oh no, my computer's about to die. And so you should get 58.82. Okay, so that has a decimal in it, so we can't do a factor tree. So we're gonna now approximate it. I'm gonna take the square root. So again, you hit Control X squared, and then arrow up to get that number, because there might be more decimal places. I don't know, there wasn't on this one. And then let's round it to 2 decimal places. So that is 7.67, and you round it to 2 decimal places. Okay, so tape that into your notes on top, or you can be over here if you really want to. Just make sure that this is all about 1-3. Everything on 1-3 is midpoint and distance and partitioning segments. And then grab your worksheet. This is your homework due on Friday. Spend a few minutes on that, and then we're going to take our exit ticket on Canvas at the end of class. I hope that helped explain all these problems.